We're going to take a look at some more things that have to do with data types. Remember, we've got 4 types of data. We've got integers called int in Python. We have numbers with fractions in them called type float in Python. We have text enclosed in quotation marks or apostrophes or triple quotation marks, and that is string data in Python. Then we have true and false with a capital T and a capital F, no quotation marks or anything, and those are the 2 Boolean values. So let's do, I'm going to do some bad variable names here because there's really no context for this. I just want to show you how to do some things. Okay, so I've got a variable s. S is, in this case, I picked that for string, and it's got a string in it. Now, we know that's a string because it's got or quotation marks around it. And if I do this, type of s, it's going to come back and tell me it's a string, even though it's a string that looks like a number. Now, sometimes you will have strings that look like numbers, and you want to convert them into a number. And so what I can do is this. If I type s and hit enter, I get the string 10. If I type int of s, that means take s and make it into an integer and hit enter, and now I get 10. And you see the difference here. It's the apostrophes. If I try to do s equals s plus 5, okay? S is a string, 5 is a number. You can't do arithmetic on a string, even if it's a string that looks like a number, okay? So now the equal sign, there's kind of a weird error message there. It says can only concatenate string, not int. So the word concatenate means to tack on. And I am allowed to change a string, s equals s plus, if I tack on another string. Okay? And now if I look at s and hit enter, I have tacked on, so this does not mean the same thing with strings that it does with numbers. I have tacked on the string 5. Okay? If I do s equals s plus, and hit enter, now if I type s, it's going to come back and it has tacked this onto the existing string of 105. But what if I want to, let's go back and change the value of s to 10 again, the string 10. And what if I do want to do some arithmetic on that though? Well, I have to convert it into an int. And if I do int of s, it converts it into an integer for me. But I'd like to save that. So let's say I've got a variable I for integer, and I want that to be the integer value of the string s. And now if I type I get 10, which is the integer 10. I know it's not the string 10 because it does not have apostrophes around it. Okay, so now I can do I equals I plus 5, and because this is an integer and 5 is an integer, if I hit enter, and now I do I get 15. So I've changed the value of I. So the plus sign, if you got numbers, means add. The plus sign, if you've got strings, means tack them on to the end. So that's really the only meaningful thing that a plus sign could possibly mean with strings. We're not allowed to do arithmetic on them until we convert them into an appropriate data type, which would be an int or a float. I can also do this. Let me type s again and see what I've got in. So I got the string 10. And if I want to convert that into a float, I can do float of s, and it comes back and says 10.0, which is the floating point version of 10. And if I want to put that into a variable, like f for float equals, okay, and now if I type f, it's going to tell me 10.0. So I've got s, which is the string 10. I've got I, which is the integer 15, and I've got f, which is the integer, the floating point value 10.0. So you can convert from one type to another simply by giving the name of the type float. I can also do this. I've got a variable I, and that's 15. I can do s equals str of I, and that will, if I type out s now, s is now the string 15. I can also do s equals the floating point value of, I don't know if we got something there or not, a string, but let's do a string that looks like 10.5. Okay, and if this looks like a floating point number, then it will convert it, and I'll get 10.5 without apostrophes when I print out S. So S is now, even though I've used it as a string before, because I put a floating point value in it, now it's a floating point. So the types of these changed if I decide to put something different into the variable. Okay. Now, what if I have something like this? S equals float 10.5x. Okay. Now, I suppose there's two ways you could interpret that. It could try to just interpret this as 10.5 and disregard the x. But what's in the string has to be a legal floating point number in order for the float function to work correctly here. So when I hit enter, it tells me that I cannot convert that string into floating point, and the reason is because of the x. It doesn't tell you why, but you can look at it and you should be able to figure out that the reason that can't happen is because we've got an x there. Python has the usual arithmetic operators. If I do 2 times 3, that's the multiplication operator. If you've used Excel before, it's the same in Excel and almost every programming language as well. If I do 2 plus 3, I should get 5. If I do 2 minus 3, I should get -1. If I do 2 divided by 3, I get about 15 sixes. Python is usually accurate to about 15 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It looks like 16 if I counted correctly. But that's usually the extent of the precision. You can also do, let's do 10 divided by 3. And I get a bunch of 3s. That's kind of interesting. I get a 5 on the end. And let's say that I don't want the fractional part. I just want to divide by 3 and get an integer. Well, there's an integer division operator that is 2 slashes. And if I do that, I get just the integer part. It throws away whatever the fractional part happens to be. Okay. So if I have 199 divided by 100, I get, 1.99. But if I do 199 divided by 100 that way, it doesn't round. It's going to give me 1 for an answer. So that's an operator that's a little bit different. It gives you an integer for an answer, regardless of what the numbers are here. If I do 10.5 and divide it by 3, I will still get a floating point number. Okay. I'm sorry. I will still get an integer, but it will be represented as a floating point number. 10.5 divided by 3 is not 3.0. There are 2 other operators that are useful when doing arithmetic in Python, and one is the exponent operator. If I do 2 to the 3rd power, it's 2 stars, no spaces in between them. 2 to the 3rd power is 8. If I want to do 2 to the 8th, I could do 2 star 2 star 3. Now, when I'm doing this, there has to be some precedence rules. Do I take 2 to the 2nd power first and get 4 and raise that to the 3rd power and get 64? Or do I take 2 to the 3rd and get 8 and take 2 to the 8th and get 256? And the way this works is, with exponents, it does the right one first. So I'm going to get 8 for that. I'm going to take 2 to the 8th. I'm going to get 256. Okay. If I want it the other way, I can always do parentheses, 2 to the 2nd power, which is 4, raised to the 3rd power, which is 64. And the last operator is called the mod operator. It stands for modulo or modular. And it's for doing modular arithmetic. And what it does is it does division and gives you the remainder. So if I do 10//3, I get the number 3, the whole number 3. If I do 10 and the mod operator is a % sign and 3, I get the remainder. If I do 11 mod 3, I should get 2. If I do 12 mod 3, I should get 0 because there's no remainder when I divide 3 into 12. Now, one possible point of confusion here. This has absolutely nothing to do with percentages. Nothing at all. It is a symbol that was on the keyboard that wasn't being used for anything else. It's on every keyboard. And the creators of Python decided that they would use that as an operator to indicate that we are dividing and taking the remainder. So that's called the mod operator, the modulo operator. And it actually, it may not seem like it, but it actually comes in pretty handy from time to time. So we can also, we can mix these up. If I do 2 plus 3 times 4, if it does the 2 plus 3 first, I get 5 times 20. Otherwise, if it does the multiplication first, I get 12 plus 2 is 14, and 14 is what I get. So the precedence rules are the same rules you learned in algebra. It does multiplication, division first, actually does exponentiation first. Then it does multiplication, division. Then it does addition and subtraction. And I forgot that above all of that, if you want to override it, you use parentheses. So if I want the addition here to be done first, just put parentheses in. Everything is exactly the same as you learned in every other math class that you've ever taken. Okay? Okay. Let's try just a few more here. Let's do x equals 5 times 2. And if I type x, it should tell me it's 10. If I want to know what the type of x is, it should tell me that that's an int. If you multiply integers together, you get an integer. If I do x equals 5 times 2.0, now I've got a floating point number in there. If I do x, it should say 10, but with a decimal point in it. And now if I ask, what's the type of x, it tells me it's a float. So you put one floating point number in there, the whole thing is considered to be floating point. Okay. Here's something kind of interesting in Python that you cannot do in most other languages. If I do 2 to the 10th, that should be 1024. If I do 2 to the 100th, I have no idea what that is, but that's a big number. Okay? Be nice to put commas in for us. If I do 2 to the 1000th, 2 times itself 1,000 times, that's a big number. If I do 2 to the 10,000, that's a really big number. Okay? But that's it. That is accurate. And in most programming languages, if you want to do something with really, really, really big numbers like that, then you have to make some other accommodations. But with Python, there is no effective limit on the size of an integer. Let's try a few more mod operations here. Let's do 10 mod 2. If I divide by 2 and take the remainder, I should get 0. If I take 10 mod 3, I should get 1. That's the remainder. If I do 10 mod 4, I get 2 for a remainder. If I do 10 mod 5, I get 0 for a remainder. If I do 10 mod 6, I should get 4 for a remainder. If I do 10 mod 7, I should get 3 for a remainder, and so on. Okay? And now let me show you a reason why you might want to do integer division and why you might want to do modular arithmetic. Let's try something like this. Let's say I've got a variable called minutes, and it has the value 645 in it. Okay, so that is 10 hours, 600 minutes, and 10 hours and 45 minutes. Okay. If I want to know how many hours that is, I can do minutes divided by 60. If I do, though, hours is going to be a fraction. It's correct, but if I just want an integer, I can do hours equal minutes and do integer division, and it will just give me the 10. So let's see what is in hours now, and I get the number 10. Now, if I take that and divide it by 60, if I take the number of minutes and divide it by 60, and take the remainder, it'll give me the number of minutes. So this number here represents 10 hours and 45 minutes. Doing this type of arithmetic, integer arithmetic, gives me an integer for an answer. And now if I take minutes equals the current value of minutes, which is 645. And I divide it by 60 and take the remainder, I should get 45 for minutes. So now if I type minutes, and I forgot to put the S on the end. By the way, you can do an up arrow here to go back up as many lines as you want to. If you do make a simple mistake in a previous line, you can just hit the up arrow and fix it rather than retyping the whole thing. So if I type out minutes now, I get 45. And if I do print hours plus minutes, I get 55. And that is not what I wanted. I wanted hours first and then minutes, but that only works if you've got a string here. So let's try doing this. Comma. And it tells me I've got 10 hours and 45 minutes, which is what I want. Kind of like to get that colon in between there, though. So let's try. I'm going to show you the best way to format stuff in Python. It's using something called an F string. And an F string starts with the letter F, stands for format, I'm pretty sure. And what I want to do here is I want to specify the name of a variable to be printed in here, and it's hours. And so the name of the variable goes in curly brackets. And then I want a colon, and then I want another variable, which is minutes. And that goes in curly brackets, close quotation marks, and the closing parenthesis for the print statement. And hit enter, and it prints out exactly the way I want it to. So here's the deal with an F statement. It's more complicated than this, but as we work our way through the course, we'll worry about some of those complications. So an F string is a formatting string. You've got to have the F directly in front of the quotation marks and then the ending quotation marks. And anything that's in curly brackets here, it will check to see if there's a variable by that name, and it'll put its value in. This is not inside the curly brackets, so it just prints the colon. And this is inside the curly brackets, so it prints out the value of minutes. And you can do a lot of nice output using F strings like this. So I think this is much better to look at than this. Obviously that doesn't work. I could try converting them to strings and putting the colon in between, but that's also a lot of work. So we're going to be using printf almost every time we want to print something out, unless it's a very simple print command. And that's probably a good place to stop for now.